My name is Ryan Chattel. I'm the product manager for the distribution automation sector of the business that's really focused on our SCADA side of the business. Again, water, gas, and electric. We'll talk about that coming up here in the introduction. Like he mentioned, I started as an application engineer, kind of working at the low-level details of the protocols, Modbus and DNP3, working at various different applications across the smart grid, and then implementing that all the way to customer SCADA systems. So I'll do my best to answer the questions that are presented to me. If you do have any technical questions, they're not off limits. So first and foremost, I always like to give a little plug to Boise, Idaho. That's actually where our distribution automation sector of our business is located. So those of you that have AMI systems or are familiar with the R&I and things like that, this is a separate sector of the Census business that's largely focused on the SCADA side of the business and distribution. That is when you have a question. So real quick, raise the hands. Who's an Electric SCADA customer? Okay, so got a couple. Water SCADA? One. Gas? Okay, so probably a couple. So I'm going to try to cover kind of examples since we have plethora. I mean, in distribution, it's truly a horizontal platform and a horizontal product, which we'll talk a little bit about. So hopefully it's of interest for you guys. But the key here is that it's separated into Boise because we have a whole sector of the business that's focused on these kind of intelligent protocols like Modbus and DNP3. I'm an active member. I sit on the DNP Tech Committee, so I really like to kind of get down into the weeds of those things. We have several that are familiar with, including John Glauser, one of our application engineers over here, very well versed in the Modbus protocols and just sampling even 4 to 20 milliamp sensors. Steve's team and John are computer science, electrical engineering. There's a lot of subject matter expertise there. Really the fundamental thing that it matters to you as a customer is when you have a super low level question on a recloser, a capacitor bank, a voltage regulator, a DNP mapping, something is fundamentally not right. You don't necessarily want to talk to a meter person about that. You want to talk to a distribution person about that. So that's why it's really kind of focused is there for a better user experience for the customer, just core subject matter expertise. So we have our application engineers. We also have our separate Boise R&D firmware, software, hardware. So I'm going to show you today some of our software. It is not the R&I. It's a platform called Automation Control. So we'll talk a little bit about that and fundamentally why it's different and the purpose that it serves. You call in our managed services support line, and you're going to get a dedicated application engineer that's really focused on the distribution side of your business that can help you out. We also have a NOC, the Network Operations Center in Boise, which is staffed 24/7, 365. We offer a lot of solutions and service to our customers, having disaster recovery and site-to-site replication. And really the teams there are focused on keeping your systems up when you need them. And especially in the SCADA world, we don't really have a sense of humor. We can't go down, and we need things up all the time. And when you need to operate a pump, a valve, or a recloser, it needs to happen right now. It needs to happen every time. So we're going to talk a little bit about those requirements. Data center operations, folks. We have 2 data centers in the United States. One is in Boise, Idaho, and the second is in Raleigh. And so the way that the Network Operations Center and the data center operations folks have designed it is a complete site-to-site replication that allows, God forbid, something to happen in Raleigh, something happens to the data center there, the entire thing fails over and goes to Boise so that you as customers are up all the time. And in SCADA, that matters. So we have those kind of services as well, solution services. And then me, marketing one. They said, all right, you were over in engineering for a while, now we're going to stick you in front of customers, and so now I give you me. So raise your hand if you're a FlexNet customer. Okay. Anybody have any SCADA that's currently on cellular? Anybody raise your hand? Cellular, okay. And that's not a problem. We've designed our network and automation control, which again we'll talk about, to be kind of agnostic of those comms, whether it's Verizon, AT&T, or FlexNet. They all reside and go into one single platform in automation control. But really the key here is that your investment was sound. If you're a FlexNet customer, the investment was sound because we are the only distribution automation offering in the market that meets the requirements of what a SCADA operator really cares about. You know, I always go back to, you know, this Pico we got over here, I'll pick on you guys for a second. The folks in the operations command center, right? The folks that are pushing the button to keep the lights on, keep the power flowing, keep the water flowing, the gas flowing, prevent critical explosions, that kind of stuff. They don't have a sense of humor. They push the button, it needs to happen right now, and it needs to happen every time. That is, we fundamentally believe we've designed a network that allows you to do that. So other people have tried other competitors, and this is really what separates Census from, I think, the rest of the pack. We do not believe you could or ever should do SCADA on a mesh system for latency reasons and reliability reasons. But the key here is that everything, you've invested in FlexNet, and everything can kind of ride on your FlexNet network, and technically speaking, your DA and your SCADA side of the business is completely separate RF spectrum. So again, I'm not going to get in the middle of Mr. and Mrs. Jones' meter read. I don't want to, and I also don't want them in my way. When I need to operate a recloser, again, I don't have a sense of humor. I got to get it done now, if that makes sense, right? See a couple nod heads. That's good. Okay, just a quick plug for the Stratus IQ for any electric customer. There's a new electric meter that kind of hit the market, and what you're going to see and what we can do in distribution is really a lot more about actionable insight and data and things like that. Stratus IQ has taken that to another level, so I wanted to put a plug in for that. If you don't know anything about it, please reach out to the metering folks. But really the focus of today is, again, we're going to move beyond the meter. Really the question becomes, what else can you do? So there's an entire network of assets out there that you own and control that can be added to FlexNet. What are some of the assets that you think that you have on your distribution grid that you want to add to FlexNet? Just raise your hand. Throw it out there. I see you thinking. Go ahead. Recloser, faulted circuit communicators. What about water, folks?
Gate stations.
Gate stations for gas, okay? Or water. Okay, so but these are all critical assets, and really, again, it's all about adding the devices on your network and getting more insight and more monitoring control into that. And that's really, again, what I fundamentally believe, and I mentioned this before, is that we are the best in the industry for a couple of reasons, and I'm going to talk about this why. So distribution automation on FlexNet, it changes the game. In fact, FlexNet is the only network that can do this. When others try, again, they try and hop, and I'm not trying to sell you on FlexNet, but I am telling you the distribution side on FlexNet is a whole other level of experience because it features these critical things to you as a utility. Number one, low latency. In SCADA, latency is king, right? Again, put your hat on as if you're the SCADA operator and you're in the SCADA operations room. You push a button. What do you think? So here I am. I'm pushing the button. I open. What do you think happens if it doesn't open or if they don't get instant kind of feedback? They push it again. What does that mean on a mesh system or latent systems? And what happens if that point is a toggle point? Whoops, I've just undone what I've done. So again, latency, like this is our number one thing, is really important. So we offer really low latency on the system, and commands are the highest priority. So the other thing that's really important to you as utilities that you need to understand is connectivity to your existing SCADA assets is really important. So you have out there your existing cap banks, your existing reclosers, and I'm not suggesting that you rip any of that out. I'm suggesting you add monitoring and control capabilities to all of them. Okay, connectivity to your SCADA system. Direct connectivity to your SCADA system. The last thing I want to do is go into, you know, some of our utilities and tell a SCADA operator, hey, I've got a new user interface for you to use. It's awesome. Got all these colors and gee whiz bang thing. They're going to kick me out so fast because they're looking at their HMI system and that's what they're used to. So we have a native plug-in to theirs, and they continue to operate and do things as if they were directly connected. And that's the kind of the seamless user experience. We'll talk a little bit more about that. Connectivity to third-party smart devices on your grid that speak industry standard protocols. And then again, it's a SaaS solution that we have that offers, that scales, is secure, and it provides you the lowest cost-effective solution because our solution in automation control, which we're going to talk about, is 100% HA. That stands for highly available. That means that there's no single point of failure in the software. That's an incredible investment that we've made into R&D to make sure that that system is there when you need it most. Okay, as I talk about SCADA and I talk about distribution, I'm really talking fundamentally, and I'm talking to everybody and kind of pick apart the pieces that apply to you. But I'm talking about freshwater distribution networks, wastewater distribution networks, electric SCADA system distribution networks, and gas distribution networks. So when I talk about SCADA, my platform on automation control can serve all of your needs. So I know you have a couple of you are water, a couple of you are gas, a couple of you are electric. Kind of keep that in mind. I'm going to focus on electric for this particular one because I have dedicated ones for gas and dedicated ones for water coming up later this week. So please, if you see what you like, want to learn a little bit more as it applies to your vertical, then please come by those sessions. Okay, so this one again, kind of peeling back the layer of the smart grid. For those that are really familiar with metering, again, kind of in the homes there, that's really your metering scope. And then if you think about it from a distribution network perspective, there's this higher level system that's orchestrating the power or the water or the gas that's distributing this power and water and gas down to where we need it most. And that's the distribution network. So I always suggest that the SCADA side of things is really the unsung hero because we never really get any of the credit, but all the metering gets the credit because they're billing the stuff. But they need us to make sure that we're reliable. So we work collectively as a team. Okay, so the DA architecture, I want to talk a little bit about this, and in the next session I'm going to get down a little bit deeper. But really it's an end-to-end architecture that provides key actionable data for people when you need it immediately. There are no single points of failure, and we're the lifeline to SCADA. So that's really, really important. Actually, I'm going to take one moment. I'm going to just talk about this slide. So the first kind of major thing to be aware of, sorry, I'll get away here. On the left-hand side is the SCADA endpoints. The key is, the biggest difference is that we're not just a dumb modem. And that's what separates us from cellular devices as well, is we actually feature grid edge intelligence down on the device. So each one of these devices right here is speaking intelligently to that controller. But the net effect and what that means to you is low data usage, and you're really feeding up that critical information when you need it most. So for example, a recloser sees a B-phase amps goes from 30 to 35. Could be critical, could be a big deal. You're going to need to know that right away. It sends that and only that over the network. If it changes by 30 to 30.1, probably not a huge deal. I don't really need to know it right now, but at least I need some information on it and it will send it up. So again, it's a grid edge intelligence device. Our solution features kind of a little mini SCADA system inside of that device. That makes sense? Okay. Then we send that over our network, and again, it's FlexNet, Verizon, or AT&T, or a combination of all three. Because as you put in your FlexNet networks, it may not make dollars and cents to apply, a couple pockets, or maybe a really far distribution feeder that's got an irrigation customer. Maybe there's only one out there. You just need one. Well, then put a cellular device out there to kind of use the benefit, right? We're trying to make the best solution for you, no matter what it means. So then it gets up to the head-end system. And again, this is where I would offer, we have two types of people at the utility. There's the SCADA folks that are in the operations room pushing the button, and there's everybody else. Everybody else matters, and they matter a lot. But what you won't have is that the SCADA folks, they don't really let you have access to their HMIs, their SCADA system, their one-line diagrams. Sometimes any reliability engineers, distribution planners in here? No? Okay. Well, there's a whole sector of the other distribution space that they start looking at reliability and start doing trend analysis and things like that. So there's two key parts to the automation control solution. Number one is a native interface to SCADA. Again, the last thing I want to do is tell them to go somewhere else and you can go into another system. And then the other user is the utility user that logs into automation control and can see the real-time information and also see the connectivity to SCADA as well. So you have the configurability to limit control to SCADA or have both of them have it, or maybe engineering have access to analog output commands, or whatever the case is. A core fundamental belief of our solution is interoperability. So again, I'm trying to be pretty agnostic in terms of what products. So as you go to Distributech this year, or WEFTech, or wherever the case is, new conferences that are out there, as a new product comes on the market, you're going to say, hey, I want to put that on FlexNet. And so interoperability is a really core component of what our system offers. And we do that in two ways. Number one, we're compliant with DNP3 and Modbus. So any product, any application that's out there that speaks Modbus or DNP3, we can natively interface and add on to automation control. No new software releases, no new nothing. You can just create a new product and add it to your system. Okay, a little bit about our core product offering. We have 4 hardware products that you kind of need to know about. The first one is the RTM2 Plus. It is our intelligent communications module. That's the one that speaks Modbus or DNP3. Whether it's a pump station, intelligent pump controller that speaks to Modbus or DNP3, or a voltage regulator on the electric side, or a gas in a reg station that speaks Modbus. These are intelligent devices that are going to speak a protocol, and that's the product that you would interface. It comes in FlexNet or AT&T or Verizon, and again, all to the same system. The next one is the T866. T866 stands for 8 digital inputs, 6 analog inputs, and 6 digital outputs. Anybody familiar with a smart gateway in here? You raise your hand. Okay. Smart gateway is a water-based product that's battery powered, and it does sampling and does, they're talking about doing pressure detection and stuff like that. Think of the T866 as the big brother to that. It's line powered, and it does real-time monitoring control up to many more digital inputs and analog inputs, and most importantly, offers control. So start thinking about the automation schemes that you can enable on your system, like when a tank level drops to a certain point, turn on pumps, or an electric. If the AC power is lost in a critical subdivision, you want to turn on a generator. Anything that you can create logic to, you can set a T866 there. Gas SCADA customers, this is a big product for you. Water SCADA customers, big product for you as well. TC032, it's electric only. It's a capacitor controller, and we've taken our product, our RTM2 Plus, and put in a capacitor controller all in one. We did this as a joint venture with a utility, actually, and we made this product, and on their 34 kV distribution line feeders, or voltages, they can, you should see their power factor during this peak of the summer. It's absolutely amazing. So it's a really cool product. And the last one is the faulted circuit indicator application. Navicom is the product, so FCI's, we've partnered with Power Delivery Products, which is an industry leader in faulted circuit indicators. And so you basically clamp on FCI's onto the line, those communicate into the Navicom. Navicom is AT&T, Verizon, or FlexNet, and that takes it out to automation control and up to SCADA. Okay, SCADA requirements. I mentioned that we didn't have a sense of humor. So what I mean by that is in SCADA, it's a real-time system that needs to be up 100% of the time, right? We cannot go down. And because when we go down, we're right in the middle of your system. So we have done everything we can to build out a complete 100% HA system, no single points of failure. If the web application is having latency issues or whatever, too many people logging in, whatever the case may be, SCADA is not even impacted by any of that. And so it's completely redundant. Let's say there is an issue with SCADA-Xchange. We have a passive node that's sitting there waiting to pick up the traffic. So trying to keep you up at all times is really important to us. Another one is latency. That's the little clock timer. We actually publish latency numbers in our software application. When you push the button to operate something, how long did that command take to get down to the field and back to be processed? Because that's what matters, right? If you're looking at other SCADA solutions, don't be bedazzled by all the throughput numbers and the this and that. Again, what matters is if you push the button, how long does it take, right? Because what other vendors will do is they'll hide, oh, well, I'm this fast between these two nodes. Again, none of that is relevant to the SCADA person, which matters the most in this particular case. Not all payload or messages are treated equal in the system. So I would offer that a command is more important than maybe somebody sending down a remote firmware update. So somebody sends down a remote firmware update to all the devices in the field. Unbeknownst to you, SCADA needs to operate the system and say, hey, I need to close a recloser or operate a capacitor bank. They shouldn't know that anything's happening. And the system is intelligent enough to go, these two things happened at the same time, boop, I'm going to put this one up front. So there's logic in the head end that allows you to kind of experience that seamlessly, and you shouldn't even have any idea as a user. Same thing on the inbound side. If a recloser operates or a voltage regulator operates, it's going to bump any just static time schedule report interval that's just checking in because it's not as important. Okay? And the last thing is security. 256 AES encryption on all of the FlexNet devices. You should be encrypted end-to-end. I can't stress security enough. We have several security features which we'll talk a little bit about in this solution, but we do try to take it to the next level. We have password management on devices. We have encryption, key rotation, system audit logs, all kinds of stuff. Okay. Admittedly, I'm being a little cute here with this slide, you plus me equals us. Really what I'm trying to say is in our platform in automation control, I'm providing you a tool set that goes beyond just the products that we sell. So let me be clear. There's three different parts to the system here. There's the base stations. Base stations are devices in the automation control system. So you can see the base stations. You can be alerted when they lose backhaul connectivity. You can see them. You can dashboard them, which we'll talk about in a second. You can see the noise floors or when there's a high noise floor on a particular base station. Again, providing you network insight. That's kind of one thing. Then there's the devices themselves, like the RTM2+. I'm providing you communication status, statistics on it, how many kilobytes was inbound and outbound, all different kinds of stuff. And then I'm also providing you, this is a SEL 651R, it's a recloser control in case anybody didn't recognize it. Our little module goes inside of that. But what if I told you that I was giving you a platform that enabled you to start tracking the battery installation dates on your devices or the time that you commissioned them? You could run a query on the system and say, show me all my batteries that are over 3 years old and start doing preventative maintenance. So I'm not just offering you a solution to our product lines, but I'm trying to provide a platform for you and an experience for you to manage your SCADA assets. Does that kind of make sense? Okay. Let's talk a little bit about notifications. You can set up custom alerts and notifications when anything occurs in the field. We have complete, who's familiar with R&I here? Who's familiar with R&I and alarms? Okay, now take all that and just put it to the side for a second. We have a solution that allows you to make anything an alarm and name anything you want as an alarm. So what if I had a high noise floor? I could set a threshold over 20 dB, for example, and say this is a high noise floor alarm. And I wanted to send it to this guy over here who's in my RF networking team to make sure he knows. Right? I can create anything as an alarm in the system, anything that's reported in. So any digital or binary input, any analog input, any threshold, and it can go to any number of people. Okay? So we're in this world of wanting a lot of information. I get it. I do too. Unfortunately, we don't always have a use case for what we need all that information for, right? So then we get really smart people that say, okay, well, we need a big data solution. And this is what we need. But then the net effect is to you guys as utilities is we end up just drowning in data. And sometimes it starts to affect our real-time systems like SCADA because we're just taking in so much information. Well, automation control has a unique solution to this problem, and that is specifically a user customizable dashboard that boils up all this really key, critical, key performance indicators and makes them actionable to the user. So in the I have a whole other module or whole other presentation on dashboard and driving performance, but you can ever see everything from base station connectivity to noise floor levels to signals on the inbound and uplink and downlink side. You can see operational latencies, how long it took reclosers versus cap controls, all different kinds of stuff. So it's user customizable. We'll go through the whole thing in that session. So make sure you look out for that. It's called Driving Performance with the Dashboard. I encourage utilities that have adopted this mindset of using automation control as an asset management system are starting to see dividends paid to them. So they are starting to see the benefit of kind of the organization of the data. You can start to customize and create. It's not as up to me as a vendor to tell you how you should organize your data. But what I've done for you is I've provided you a platform that says, hey, how do you want to organize your data? You can create structures like application types and start to say, which one of these are reclosers, which one of these are cap banks, which one of these are voltage regulators. You can start to then filter and query and say, well, I also care about what distribution feeder they're on. Is it a 34 kV? Is it a 69 kV? Is it on my 4 kV circuit? You can start to organize things, and it really starts to help you out in the field as you start to scale up. So specific alarms, switches, anything, battery installation dates, device installation dates, really anything you put your mind to. We've created a framework that allows you to organize and create your system as you want it. We're doing some things that give some utilities a little bit of uneasy feelings. And what I mean by that is automating things. There's two schools of thought. There's a school of thought that says, no, I'm going to control it and I'm going to manage it and I'm not going to let automation occur. And then there's other schools of thought that are like, well, I'd really like it if I didn't have to manage it. Let me give you an example of a water. Who's water? Water? So in an overhead storage tank, let's say water drops to a certain point, turn on pumps. Overhead storage tank starts to overflow or almost overflowing or whatever, turn off the pumps. Electric example, you lose AC power or somebody enters into your substation. Send a notice to somebody, hey, the door's open, right? And automatically, you know, okay, it just came to a story. Westar Energy was a customer that I worked on 8 or so 9 years ago, and they had a substation that transients were breaking into. They were trying to steal copper. And all joking aside, there were seriously fatalities that happened because they wanted to avoid this. So what we did is we hooked up a T866. We detected if the door was open or closed because they were always breaking it. And then we turned on a bullhorn. Boop! You're messing around where you shouldn't be. You hear a bullhorn, you are gone so fast. And so we turned a simple automation scheme into something that really solved kind of a bigger problem. So what can you use it for? Pretty much anything. Along the lines of operations, everything in my system is audited. Who logged in? What IP address did they come from? Did they lock out, or did they fail too many login attempts where they locked themselves out? Who sent that command? Who deleted this account? Transparency to the network, and especially, I mean, security is no joke. We have to make sure that we're staying ahead of it, and you always got to be thinking about the next level stuff. I also provide you an engineering toolkit on kind of different use cases. Let me give you an example. In this particular case, electric customers, raise your hand again. You could rip across all your reclosers and start to look for phase imbalances. What if I could tell you all your 651Rs, you could plot them against each other and say, show me my A phase amps, my B phase amps, and my C phase amps. And I can look at them and go, oh, B phase is at 79.2 and A phase is at 140.6. Well, maybe I'm imbalanced. Maybe I need to look at that. So again, providing you that actionable insight is something that automation control really prides itself on. Again, network management. FlexNet customers, raise your hand again. Okay, base station backhauls. If that base station goes down, you have a dashboard tool, a tile that you can see and see if that's connected or not, as well as being able to get any alarm or any notification. You can start to see things like environmental alarms, anything that you can classify as an alarm, noise levels on your base station, etc. Customers with SCADA systems. who has a SCADA system. If it's DNP3, I can connect in and I can plug in directly and let your SCADA system, your SCADA folks continue to kind of operate, whether it's OMS, EMS, DMS, doesn't matter. So this is what SCADA-Xchange really offers you, is it's a native interface that allows you to connect into your system. And then lastly, the last slide here is really kind of just in summary. The distribution automation, again, this is an introductory class here. It offers you a ton of things. It offers you SCADA interoperability, asset management, alarm management, communication monitoring. It's a real-time application. You can operate devices in real time, group commands, stop by the demo booth. We'll show you the operation of a recloser, for example, show you the latency on things like that. Creating automation in my water and in my gas. I'm going to actually do a demo. I brought a demo box and do some demos of simulation of water and simulation of gas, SCADA in real world. Google Maps interface, you can see all your devices, etc. Dashboarding, we also feature 13 months of history. So you can start to plot this distribution feeder across 13 months of history and start to see anomalies and when they occurred, kind of seasonality and things like that. Security is a really important thing, and then LDAP and the system audit log is the other thing. So, okay, well, thank you guys. I'll let you go a little early.